Hello everyone, I'm Francesco and today I will be talking about the Oniro project and our technical journey toward digital independence. So let me start with the digital sovereignty problem. For over a decade, mobile computing has been dominated by a couple of platforms, and this has concentrated power into the hands of few companies and created a structural dependency that conflicts with European values and priorities. So think about it. Every phone, every tablet, every device we own runs one of these two platforms. So this is just not just a technological choice, it's also about a problem of digital sovereignty. And Europe leads the world with data regulation and digital market regulation. We have GDPR, we have a Digital Market Act, but how can we ensure that these platforms are actually open and they follow privacy standards and security requirements when they're not open and they're not locally accountable? So what Europe needs is alternatives that delivers strategic independence with a platform that we can trust and that are open. We need multi-device reach because digital sovereignty is not just about one device, but it's also about the ecosystem of connected devices. And we need compliance with European regulation from the ground up. So this is exactly what Oniro is building. Oniro is an open source project, it's an operating system, and it's managed by the Eclipse Foundation, which is a European open source foundation, and that makes it a truly European project. The platform is built on the solid foundation of Open Harmony, which is a mature project. It's quite a big deal in China. It has already hundreds of products, it has thousands of committers, and it has millions of lines of code. And the project operates under a unique dual foundation model. We have the Open Atom Foundation in China, and we have the Eclipse Foundation in Europe, and together they share technology while maintaining local governance. And this allows us to have the project to scale globally while maintaining a regional trust. So our mission is to build a platform that is cross-device and accessible for global developers. So Oniro acts as a bridge of Open Harmony to the wider world. And however, there are some barriers for an international developer to adopt the Open Harmony platform. There might be unfamiliarity with the platforms. For example, Open Harmony repositories are hosted on Chinese Git platforms. There might be language barriers and also limited access to familiar and accessible devices and tooling. So Oniro tries to remove those barriers. For example, we have daily synchronization with GitHub mirrors. We have documentation that are English first, and we have support for hardware that are globally available and supported. And we have tooling that are developer friendly. So one example of tooling that we provide is the Oniro IDE. So for Open Harmony and Harmony OS development, they provide an IntelliJ IDE called the Vico Studio, but we wanted to provide also an open source alternative as a form of extension for Visual Studio Code. And the key features include SDK and command line tools management, direct integration with the Oniro emulator, generation of debugging signature, building of application packages, and deploying them on the virtual device or physical device, and filtering the logs. And the advantage of using this IDE include a fast development workflow using a code editor that is familiar to developers worldwide. Many developers already have this installed. It has support for Linux. It doesn't require Windows like with the Vico Studio. And it allows for AI-assisted development using other extensions for VS Code. And this lowers lowers the entry barrier for new contributors. So once the developers has a place to code their application, they might need a place to test the application. So that's why we provide the Oniro emulator, which is a QEMU emulator, QEMU based. And my technical approach to bring up this virtual device started from building a Yocto meta layer, applying OpenHarmony Linux patches, and using LXC containerization, I was able to achieve graphical support using Mesa drivers. And successively, I integrated the platform into the OpenHarmony build system and have it running without containerization. And it also supports x86 architecture, so it allows for hypervisor and or KVM acceleration. So this enables rapid testing of application and system features using also direct integration into the IDE. And it also allows for CI/CD pipelines and fast prototyping of system and application features. So this allows Oniro and OpenHarmony to be accessible to everyone, also without the need for physical devices. So once the developer has tested the application on a virtual device, they might try to run it on a physical device. And Oniro also expanded the support for physical hardware. So we started with IoT and embedded system at first. OpenHarmony provides reference boards, for example, the Hopran board based on Rock chipset, but also Oniro added support for the Raspberry Pi, which is a globally available development board. And more recently, we also expanded support for mobile devices. The OpenHarmony community has the developer phone based on Unix chipset. The community also ported the platform onto existing mobile phones. And as part of the Oniro project, we have also initiative to bring up a truly European mobile reference device in collaboration with German vendor Volla. So our goal is to expand the platform to globally available hardware. However, there are some problems, some challenges in porting to mobile hardware. And the main one is the use of proprietary drivers. So often, manufacturers do not open source their drivers. Drivers that are usually built for Android, for Bionic Eclipse, and that makes it incompatible with open source alternatives. So in the adaptation layer, there might be binary blobs that creates vendor lock-in and reinforce platform monopolies. So this is also recently recognized by the Free Software Foundation with the LibrePhone initiative, which aims to reverse engineer those binary blobs and removes this obstacle to truly free mobile phone. And as their lead developer acknowledged, making fully free modern phones is not easy, but it's the long-term solution. Oniro also goes with a more pragmatic approach of integrating an adaptation layer using libhybrids, which translates Android calls into OpenHarmony calls based on MazoLibc. So this allows us to bridge proprietary drivers for open systems, and it allows for the use of GPUs and peripheral support. Although this is just a workaround, it's not ideal because these binary blobs remains black boxes, and we don't know what happens in them. They might be sending data across continents, we don't know. But so this is a temporary approach, and it allows us for unlock Oniro for existing mobile devices. So what are the advantages of using our platforms compared to others? One advantage is that it's designed to be able to run across multiple device classes. We have a target for the mini system that are, for example, sensors and wearables devices that runs on MCUs. We have a target for a small system, for example, for cameras and routers, and a target for a standard system for more powerful devices with screen and GPU acceleration, for example, phones and tablets. One other advantage of this platform is that it's designed to be cross-device interoperable. It has multi-kernel support. We have a LightOS kernel for real-time applications, and we have the Linux kernel for more powerful devices. It also has a hardware abstraction layer that allows for using unified drivers to simplify portability. And it has seamless device discovery and communication, distributed capabilities for data synchronization, remote app invocation, and device virtualization. One other important aspect for the adoption of open source platform alternatives is a strong and global application ecosystem. And Oniro tries to also to expand on this. Oniro provides an application store to distribute open source application. It's an idea similar to F-Droid in Android. And the community also is porting popular application into the platforms, including, for example, SoundCloud and Telegram. And one other strategy that Oniro used to expand the application ecosystem is the integration of cross-platform frameworks. For example, we added support for React Native, and that already has hundreds of applications already available. We're also doing research on integrating support for Kotlin multi-platforms and Flutter and other Rust-based frameworks. So looking ahead, we plan to have a wider application ecosystem through a wider integration of third-party frameworks, a stronger developer ecosystem, and more phones and form factors, including wearables and PCs. So I invite you to join the Oniro community and through our channels. I'll invite you to join the Oniro workshop this afternoon, and thank you.
Thank you very much. Thank you very much, Francesco, for your speech. Is there any question for this project that addresses a big issue? Because as Francesco said, all our mobile devices are depending on two operating systems that are coming from one geographical location, and this usually isn't good. Anybody? Francesco, do you know already what's the grasp in Italy for the Oniro's community?
So we hope it to be more expanded as a community.
Talk close to the microphone. We need more people there.
So we're expanding our community, and
because I saw the problem of the language. I was also wondering, what's the support from the LLMs for coding? You know, if we are coding for Android or iOS, we got plenty of support. You just ask ChatGPT to a few functions, and it's a snap. What happens with Oniro?
So we use as a programming language an extension of TypeScript. So it's a well-known language. It's based on TypeScript. So LLMs already knows. I already tested this with the creation of some applications, and it works well. It works well. Yeah.
Okay.